Good afternoon, everybody, or labas vakaras. Did I get that even close to being correct? Doesn't sound like it. Hope everybody is having a great build stuff. Wanted to say, I go to quite a few of these conferences, and you guys are extremely lucky. This is very well put on. Thank you to all the red shirt volunteers I've seen. It's been a great experience for me so far, and I'm extremely excited to be here. As evidenced by my accent, I am a American. I work in Kansas City, which is in the very middle of the United States. And what I'm here to talk to you about stuff is OWASP and the vulnerabilities, or the OWASP top 10, and how to help prevent yourself from ending up in the news or losing your job. I build a lot of stuff, right? I mean, the conference here is build stuff. I'm not a security professional. I'm a solutions architect. I work with a team of developers. These are, and it was called out in the keynote this morning, these are kind of like my base level competence that I expect for for developers on my teams to be able to know to help prevent security vulnerabilities. All right, let's go ahead and get started here. I mean, one of the things we got to remember, the purpose behind all this, right? So OWASP is a nonprofit charity in the United States. It was formed way back in 2001 when web security was terrible. Web security is still pretty bad, unfortunately, but they've done quite a bit to help. What they strive to do is to provide a bunch of free resources to everybody that you can use, free of charge, done by security professionals to help improve security web projects. Okay? Besides what we're going to go over today, the OWASP top 10, they also include a bunch of great other free projects. Like there's the a great cheat sheet series. There's Docker images that let you pull down attack proxies, and there's dependency checkers and all this other great material we'll cover just a little bit. All right, so what we're really going to focus on is just the top 10. So these are a top 10 most common vulnerabilities found on the web. You know, when we see in the news all the time about Facebook or Twitter or all these other breaches of security, it's not ninjas attacking a data center, right? Like this is almost always somebody has a coding mistake or something else that we're going to cover here in this top 10. These are very preventable, and I've seen them all the time and continue to see them all the time. So we'll go over some practical real-world times where I happen to see these. We'll be reviewing the 2017 version. So these versions tend to come out every couple years. This one just came out almost exactly a year ago. It supersedes the 2013 version. How they come up with this rating and ranking is they base it on how easy it is to attack. Okay, so something super, super easy, then they'll just go ahead, it'll be ranked higher. How prevalent is the weakness? How easy is it to detect it? What is a technical impact? Like, if someone gets access and is able to break it, does it really hurt you? Or is it just like, maybe they can scrape your logs or something like that? So that is our guiding light there. So the primary aim is to educate. It gives you resources, lets you detect patterns, and helps you mitigate these vulnerabilities in your applications. And they really want to just give you the most basic patterns. Again, a lot of these are easily seen and detected once you know what to look for. And frankly, about the top 7 are really pretty basic stuff. There's 2 of these we'll go into a little more in depth that are actually technically quite difficult to understand. But a lot of these are kind of common sense stuff. But if you don't know them, you don't know them, right? So here's our top 10. So we'll go over each of these in detail. Again, they rank them in severity. So the very top one there is considered the most prevalent, hardest one to go over. By the way, I forgot to mention, there is a sample project attached to this, and the slides are available on GitHub. I have the link, and I'll bring it back up at the end, so you guys can pull down and take a look at the code, play with it. Although, please don't try to use any of it in production. Please. All right, let's talk over it. Injection. So, show of hands, how many people are primarily .NET devs? Quite a few, okay. How How many people are maybe Java or JavaScript? Java, let's start with Java. Couple hands. JavaScript, TypeScript? Okay, got a pretty good representation. While we're focusing on ASP.NET, I myself program a lot in JavaScript, Java, and .NET. I will try to call out when you can see some of the same type of stuff in these other languages. Many of these patterns are common in other languages, but the demo project, again, is done in .NET. So let's talk about injection. Oh, how many people know what the webcomic XKCD is? Okay, not bad. So this is it's a funny comic telling us in 4 panels, what a SQL injection vulnerability is. Did you really name your son Robert Drop Tables Students? And yes, he did. We call him Bobby Drop Tables. So a SQL injection vulnerability, at its most basic, is that, or an injection vulnerability. It's allowing you to inject arbitrary commands and execute them on the system. This is a humorous example that presumably would never actually work, although I have my doubts. So here is the sad part about SQL injection. It is a 3-time champion, 2010, 2013, and 2017. Still extremely prevalent in the web today. I have seen this, I usually see this about 2 or 3 times a year, personally experienced. The worst one was about 9 months ago. A big Fortune 200-ish company in the United States. Their authentication portal was, whatever is in the username, it would just accept any input and let it be executed arbitrarily. So I see this constantly, which is why it's still the top 3. So let's see here's how the threat agents work, right? So how this vulnerability works in the very basic thing is, we say SQL, but it can be stuff like Mongo, it can be stuff like LDAP, it can be any database source. But if those sources aren't properly escaping user input, then you can allow them to execute arbitrary commands. So how big the threat is depends on what they're executing against, right? A lot of times, again, it's database specific, but it can be quite a few other ones. How common it is. It's extremely common, especially in legacy code. If you're coding in .NET or some of the newer stuff, like if you're writing even TypeScript, a lot of times ORMs will take care of this for you, but not always. And again, it's extremely common in older code, and it's also common when people don't consider stuff like LDAP or XPath and those type of other injection places. Now, the impact is severe. As shown by the XKCD comic, like once somebody can execute arbitrary things against your database as whatever the database user is running at, that's probably going to be pretty bad. That can be everything from scraping user data, dropping tables, corrupting, escalating privileges, whatever. So here is what this looks like. Let me show you real quick. Let me swip over here to my amazing demo project. All right, it's just a MVC app. There's nothing very special about it. Again, it's really just designed to show you guys what these examples look like in the wild if you ever see them. So here is our, it's a blog. We have a controllers class. Nothing super special here. However, what you'll see, if I scroll down, by the way, if you download this and grab this GitHub package, all of these are commented with like A1 injection. They're all labeled so you can just search and find them. But this is a good example. So I have a create action on my blog. I'm trying to create a blog post. Well, I take in, just standard ID, body, author, right? Here's the problem. I execute a SQL statement, and I just run insert into comments, and then I just raw pass in the values. I don't check them for anything. If you do this at any point, you are vulnerable to SQL injection. If a user can craft, if I put in here, backtick drop table, what is this, comment, it would execute that drop table comment. So this is a good example of if you're ever seeing, this is what it's like a smell to look out for. If you ever see raw SQL like this, and you're seeing just it pulling in straight user data and executing it, you are certainly vulnerable to any sort of injection, unless there's some other mitigating factors behind the scenes. Like there are some WAFs and some advanced detection stuff that can prevent this. The easiest way to fix this, how many people use like an ORM pretty often, like Entity Framework, and Hibernate, something like that? Okay. Good amount. Honestly, the easiest way to prevent this is just use an ORM. EF Core has never been vulnerable to this. It parameterizes all SQL inputs by default. So if I had just done this way of doing it, where I just did a, come over here, where I did a context save changes, like that takes care of it. By default, EF Core will, or any entity framework, or pretty much any ORM, will go ahead and save that. Same again in Java and other libraries like that. So this will take care of if you're using ORM. If you're not using an ORM, a couple other techniques is you can use SQL sprocs, aren't usually vulnerable to this. Extremely rare exceptions. Parameterized inputs. There's a couple other methods of mitigating it. We'll go over here real quick. If for some reason those aren't available to you, like perhaps you're using an older framework or something like that, the other things you can do, you can escape all user-supplied input. So this is the least preferred. You can start doing stuff like, well, if I'm expecting a first name, somebody probably shouldn't be throwing a bunch of alphanumeric characters in there and try to run that. In addition to that, OWASP themselves puts out a couple parsers that attempt to parse input and whitelist certain characters and remove stuff that will cause SQL injection vulnerabilities. All right. So here's our second one, broken authentication. We covered this a little bit in the keynote if you guys were there with Sam this morning. If you guys didn't have too much of a fun time at the party last night. Here's what broken authentication means. So most of the time, if you don't use a well-known authentication framework or you have something wrongly set up, attackers will exploit this. Okay? What they're able to do and why the attack vector is app-specific depends on how bad the vulnerability is. Okay? So an example of this, right? Most recently, I myself saw this working at a major US telecom, and somebody accidentally shut off the validation that a user's cookie that we passed to authenticate them should be validated. So they just forgot. The web server just didn't check. So fraudsters found this out within about a week, actually maybe 5 days. And in about 3 hours, they had successfully bought something like $10 million in free iPhones. It's problematic because they were able to impersonate the users, buy iPhones on their assumed account with their saved wallet, and ship them to other addresses. The prevalence of this guy, so that's how severe the impact can be. It really just depends on what a user is able to do. How prevalent it is, it's widespread. And the reason it's widespread is because people aren't implementing well-known frameworks. Authentication, authorization can be hard. People are leaving default stuff set up. People aren't properly running through passwords and session management. So it is fairly common, which is why it's a second. And the reason the impact is severe is, again, if you're able to exploit authentication or session, you're able to impersonate other users or even impersonate admins, you're able to break all the barriers around your app, right? The other way I've seen this myself is a lot of times, we actually went over this a little bit in the keynote. When you go to log on to a website, you forget your password. Happens to everybody, right? So you click, cool, could you send me a forgot password link, right? And I get my email, I check, and there's a forget password link, and it's got my password in it. It's problematic. That means somebody is storing my password either unencrypted or using reversible encryption in a database. That is just one example where you type of see this. The other thing I consider broken authentication is what we were talking about, where maybe there's arbitrarily password restriction length, that type of thing. So what this looks like in this demo here, and this is one of the ones I see a little bit less common nowadays, thanks to the prevalence of a lot of good frameworks, but I do still see it. Okay. So if you ever have to store a user's password, people get confused. Encryption's tough, right? Asymmetric, symmetric encryption, halving algorithms, DES, triple DES, all this stuff is kind of confusing. It takes a little time to understand and know. So I will often see this type of behavior, and this example is actually pulled from real life code about a year ago. So I have this method here. So somebody's like, cool, I have a password, I need to store in a database. I know I'm supposed to hash it, so let's go ahead and do that. So let's take a look and see what they did under unsafe storage here. Okay, well this, at first glance, might look okay. You see there's an encryptor. Okay, well, that looks fine, right? Does anybody know, there's a salt even? Does anybody know off the top of the head, just looking at that, what's wrong with what they're doing here? Problematic, yeah, using the salt as initial value is problematic. The real key thing besides that is using symmetric encryption, AES. It's a symmetric encryption. So with the difference between symmetric and asymmetric encryption, symmetric encryption just means if I give you my name, Bill Dinger, and I give you, you can take a key, encrypt that, and put it in a database. If I take that same key, run it back out, I'll get Bill Dinger back out, okay? Two-way. Asymmetric encryption, once I give you my name and you put it through the hashing algorithm, it creates garbage. You can't, computationally infeasible to reverse what that value was, okay? The whole point being that you should never need to know what a user's password is. You should be always running a hash, asymmetrically storing it, and that way, even if somebody gets access to your keys, they'd have no way of knowing what the user's password was. They'd only have access to the hash value. This is why it's always scary when I see, again, emails coming to me with my password in them. That means they're storing it in the database symmetrically. The way to fix this, .NET provides this, Java provides this, JavaScript does as well. There are a couple password algorithms that are designed, again, designed explicitly for passwords. The other problem we have recently with passwords with some of the older hashing algorithms is, thanks to Bitcoin, buying rigs that can run through trillions of SHA hashes is neither hard nor particularly expensive compared to what it was just a couple years ago. So security researchers came up with a couple algorithms that are solely designed to make hashing computationally infeasible. So like this guy, RFC 289 derived bytes, just rolls off the tongue, I know. That one just basically runs through your password tens of thousands of times and hashes it over and over and over and over again. The sole purpose being to try to prevent somebody who's got a nice Bitcoin rig from just cracking all the passwords in your database. If you don't use something like this, this is really stark. I almost ran the demo, but my machine, in a fit of Atlantic rage, I lost a fan, and it blue screens if it gets too hot. So I was afraid of doing this live. But any decent graphics card, if you're just using a normal hashing algorithm like a SHA-1 or SHA-512, which like, yeah, that seems normal, any normal graphics card can probably crack that sucker in about 30 minutes, maybe 15. And that's a normal machine, right, against like a 10,000 user table. You start buying these Bitcoin machines, it'll go within seconds. So that's why you should, the correct way to store passwords, again, using that, one of those custom design algorithms. Like I said, .NET provides one for you, which is great. Other frameworks have them as well. All right. So there's a couple different things that commonly come up when we talk about broken authentication. Oops. So here's the various protections. Again, we went over encryption. But the single biggest piece of advice I can give as far as authentication and broken authentication, OWASP puts out a cheat sheet series. Hey, if you need to store a password in X language, here's a cheat sheet. They have them on Python, Java, JavaScript, TypeScript, .NET, all of them. Follow the cheat sheet. All it is like, do exactly these things, and you will be okay. So the other biggest thing is using well-known implementation for authorization and authentication. Don't try to roll your own, right? Rolling your own authentication is like rolling your own encryption. You're destined to not get it correct unless you happen to be a genius. If you happen to be a genius, why are you rolling your own authentication? Do something cooler. Hopefully. Other cool thing, implement and require multi-factor authentication in case something terrible happens. We alluded to this in the keynote. NIST standards. So there's a bunch of NIST, again, the US government's National Institute of Standards and Technology guidelines on how to store passwords, how to make users have them secure, that type of stuff. A3, sensitive data exposure. So here's what we talk about this. So what this one is rather than directly try to break hashes, steal keys, exploit weaknesses in authorization, authentication, don't do any of that. Instead, let's figure out where they didn't protect the data, okay? I like to call this the Snowden vulnerability. So what this means is the NSA, National Security Agency, United States government, was like, we can't crack all this crypto that people are using. But inside the data centers, nobody's using crypto because it's computationally, or at least computationally intense. So let's just put traffic sniffers and capture all the data between all the cloud farms. And that's exactly what they did. So what this means is when an attacker finds some place where you're not encrypting stuff, some place where you're not properly securing user data. So the reason it's rated severe is typically if you're encrypting something, it's important, right? So if you're usually able to break that encryption or skip past it, that's problematic for you. Again, the prevalence is pretty common. The most common is just people don't encrypt. I'm finding this less and less, thankfully, but it does still happen. You know, with a lot of the modern cloud tools, everything's kind of encrypted without you having to worry about it. With that said, it still does happen. The other one you often see is weak algorithms, like people not picking the correct stuff, people storing keys on plain text in their hard drive, that type of stuff. So again, the impact is usually severe. If somebody's able to break your crypto, they're able to gain access to whatever they want. My personal exposure to sensitive data is two things. First, I used to work for a state government back in the United States, and we had, backup tapes. Backup tapes are still a thing. Shout out to anybody who's still going to deal with backup tapes, my heroes. So we had all these backup tapes, and we would, put them on the thing. We'd ship them out by mail. So one night, somebody was doing their job, grabbed the backup tapes, put them on the thing, set them out on the desk, went home. It was like, cool, the mail guy will come pick it up. Those backup tapes went missing. Those backup tapes had, every single sensitive piece of data information you can imagine on citizens of the state. Like social security numbers, medical history, payment details, everything. Luckily enough, we had to call the state patrol. Luckily if they were found, they were just misplaced. But that's the type of stuff we mean, is like a malicious person could wander around an office, look for, oh, that's a pile of hard drives out of a server or whatever, and try to use that to exploit and get data. The other one I've seen this on recently, this is quite common honestly, is logs on servers. And this happened to Target. Logs on servers where there are just a million credit cards in them, because people forgot to encrypt the logs or forgot to escape out the credit cards. So let's take a look at this, what this looks like in a real life example here. Okay. Whenever I switch my monitor, I'm always like, come on, don't kick on, fan. I don't need you to blue screen on me. All right, users controller. Okay, so we have a users controller in here, right? It's just like I'm creating users. I'm, right here. So I'm creating a user on my blog. Everything looks pretty good, right? Creating the user, adding a salt, grabbing my password, adding it to the database. The problem was, I like to call it Johnny Junior Dev. It's probably troubleshooting something. And what Johnny didn't think of is, what Johnny didn't think of when he was creating this is something pretty simple. He's like, I'm going to add a very helpful toString method, right? Just going to override toString. I'm going to write out their first name, last name, username. Uh-oh. I'm also going to write out their password. I've actually seen this in real life. Like, it's funny, but like I've seen this, that people do this. Or, deserialize an object and spit out the deserialized object to the file system, and that deserialized object has the password on it. But this is a good example. This is the type of stuff that'll kill you. You don't realize it, right? If you guys who attended Russ's keynote last night, he talked about like dark debt. This is the type of stuff that's dark debt. Like stuff you don't realize is happening behind the scenes. So this is a good example. So we are absentmindedly logging out the fact that the user's password is being tossed in our logs. Easiest way to fix it, again, comment out the users, never log out passwords. Yeah, if you use a well-known framework, like something like Log4net or pretty much any of them, honestly, they have various patterns. They'll try to look through your logs, and if you happen to be trying to log out sensitive data, they will automatically escape it or warn you. So protections, right? First off, encrypt everything at rest and in transit. It's a pain, I know. It's less of a pain nowadays, but still nobody enjoys and relishes setting up HTTPS certificates, SQL database encryption, and all the rest. Don't store any sensitive data unless absolutely required. Thanks to GDPR, this is actually somewhat like a law. It's not so much in my home country, but nowadays it is here. Ensure strong key management is used. So speaking of federal stuff, FIPS 140 is the US government and the NSA certifies cryptographic methods. So Microsoft says, here's a pile of code. NSA, you need to certify this as the federal government can use that in all communications. Everything from the president doing whatever the president does to nuclear launch codes, okay? FIPS 140 algorithms, they're so expensive, Microsoft hasn't recertified them in like a decade. But you can see there's actually .NET namespaces that are labeled FIPS, and those are all the FIPS certified stuff, and they're still there and they still use it. So basically use a well-known algorithm, not something randomly you found on the internet, please. All right. A4, XML external entities. This is the hard one, I think, out of all of them. This is brand new in 2017. Okay, so here's what this is. With this, attackers can exploit vulnerable XML processors if you have certain preconditions set up. Now, luckily enough, this is somewhat less common nowadays. Just because a lot of times we're handling JSON nowadays, we're not usually directly parsing XML. But they can use this, if it's enabled, to execute arbitrary code on a remote server. Hence why it's rated pretty high. This hit the Java community really hard about 2, maybe 3 years ago. A lot of old school SOAP-based services were found vulnerable to this type of stuff. So what this means is, by default, a lot of the older code allows a part of this XML spec, which allows you to specify an external entity. Makes sense. I have a document, I want to specify, cool, I want you to load an image from over here. Right? And then my XML gets parsed and the image gets spitted. Made great sense when XML was made in 1970. It makes less sense now when they could say, I want that external entity to be a log file on the server, or I want that XML entity to be a config file that might have a database connection string in it. So these flaws are usually used to extract data from the server. There are also some cases where a user can use this to guess details about your system, right? Whether that's scanning it to take a look, like is this on Windows, is this on Linux, just kind of probes, right? Just using these to say, like, give file allocations here, 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 here. I think we just lost it, Jenga. Giving file systems here, here, here. You know, figure out if on Windows what version of .NET, that type of stuff. Okay. So the easiest ones I've seen it here, let me show you what this looks like in .NET. Now the good news for this, good news being relative, is that if you're using .NET 4 and higher, or 3.5 actually, and higher nowadays, and you've run patches in the last 2-3 years, you aren't going to probably see this. But if you have, if you have older code than that, you are going to see it. RSS control. Okay, here's what this looks like. So RSS controller. Yep. Here's what this looks like in the wild, and it is a little bit weird to see. So I have this XML. Can everybody see that, by the way? Cool. Seeing some nods. Okay. Seeing some XML out here. It looks normal, normal, normal. Here's this XML D2D. I'm saying entity, file system, read this file. See users bdinger documents text.txt. Without this flag turned off, this will arbitrarily read this file off my file system. And the flag we care about is this D2D processing.parse right here on XML reader. Again, by default nowadays, this is disabled. This is set to none. But if you turned it on, maybe you thought you needed this, you are vulnerable to these type of attacks. So if I executed this, and if a user is able to process this, it would go ahead and, what happened to my RSS controller? There it is. I would go ahead and execute this and spit out the results of this test file. Easiest way to fix this, again, newer versions have this disabled, but if you take a look at this enumeration here, this DTD processing enumeration, you'll see that there is a, well, whenever my machine could, yep. So there is an ignore, a parse, and a prohibit. By default, it's set to prohibit, which means that if it's processing this XML and sees these external document type definitions, it'll actually throw an exception. But you can also set it to ignore. You can set it to do a couple different things. In our case, I usually leave it as a default, which is going to be prohibit. And I said this is more common, at least in my experience and the community in general, in Java-based applications, not necessarily in .NET. Just because we tend to write a lot of SOAP in Java, we did not tend to do it in .NET. All right. So again, to fix it, disable DTD processing. There's a couple different protections we can use besides that. Don't use XML. It's 2018. Use JSON. I mean, that's the most reasonable one. But no, all seriously. You can use JSON. You can update your XML libraries and parsers. You can, again, disable it like .NET does by default nowadays. If you absolutely have to leave this enabled, positive whitelist. So say, cool, I'm allow DTD processing, but only from this directory. Don't let it scan arbitrarily across the entire file system. All right, broken access control A5. The best real-life example of this happened about 3 months ago when it was discovered that Facebook, for a couple weeks, or maybe it was even longer than that, if you went to a view profile, you can gain access to another user's data. I was one of the ones affected. I was like, why am I being prompted for my Facebook password? Like, I have 2FA turned on. What is happening? It's because they weren't properly checking. So let's look at the threat agents and attack vectors. So exploitation of access, every attacker really wants to know this. This is a core skill for any attacker whatsoever against you. So it can be hard for automated scanning tools, what we call SAST and DAST tools, to detect this vulnerability. But a human with a decent amount of skill can start doing stuff like stealing cookies from another user, trying to hit APIs, trying to see if users bdinger can hit somebody else's API and pull their data in using their ID. These weaknesses are actually pretty common, mainly because they're hard to test for, and they're hard to program against if you're without paying attention to them, and people aren't necessarily thinking about it. Think about this. When you build your API, right, you're building your nice, pretty REST API. You know, how many times I've been like, that's cool, it's a great REST API. How are you checking to make sure user Z actually should have access to thing he's requesting? And oftentimes the answer is, oops, like we didn't consider that. Other one, I've seen this honestly all the time nowadays in production, is you'll query something, users bdinger, whatever, account, and it gets back on account ID. Well, what happens if I query the accounts and increment the ID by 1, and all of a sudden I get somebody else's user's data back? Because nobody's checking to see if I access that resource. Again, the technical impact really depends on what the user is able to gain access to. If they're able to breach your security, usually that means they can grab whatever data they're able to gain access to. That could be, maybe they're able to impersonate an administrator. That's problematic. Maybe they're able to grab personal details, et cetera, et cetera. So let's take a look at, again, this one is most common seen on APIs, in my experience, where we're not properly checking for, here we go. We're not properly checking for access. Okay, so I have a create blog post. Everything looks great. The problem is I'm not checking to see if a user should be authorized to create a blog post, right? There's no authorization set up on this. So because of that, because there's no authorization, anybody at all can just hit this randomly and create blog posts. Now, would that necessarily be catastrophic to our users? Maybe not. But again, if this was something different like delete user or get user's personal details, then it can be. So the easiest way to fix this again in .NET is just make sure you're using a well-known authentication scheme, right? Use the authorize attributes, if I can type, specify groups, double check that a user, don't assume that a user isn't going to attempt to be malicious. Always validate. Always check for access before you allow them any access to any entity inside your data and inside your application. And always assume that somebody will try to probe your application for vulnerabilities, no matter how small you are. I've seen actually this really impact a small local business. One of my wife's friends had a small local business selling some things, and they weren't properly checking API actions on like post credit card payments. And next thing you know, I think they had to pay like $5,000 or something like that to MasterCard because of fine, because they exposed a bunch of credit card details out to the internet. And the credit card payment processors do not like that. And that was a teeny tiny local business, right? But somebody just happened to start scan for vulnerabilities and find it. All right. Okay, so next one, A6, security misconfiguration. My subtitle for this slide, and I apologize for the language in advance. It's 2018, patch your fucking servers. Like, seriously. Like, we went over this a little bit in the keynote, too. Sorry, it frustrates me endlessly. So what security vulnerability often means is, again, attackers will attempt to exploit unpatched flaws, right? You're running an ancient version of whatever, and it's a vulnerable security thing. Those are usually pretty easy to detect. An attacker will run a toolbox to gain access to things. The other stuff they try to do, maybe you left your SQL database set to admin. I see it all the time, sadly. Maybe you left default administrator accounts, all that type of stuff. Maybe you're not turning on protections, you leave firewall disabled. All that group falls under security misconfiguration. So it's pretty prevalent, right? It's honestly astonishing to me how prevalent it is nowadays, even after everybody knows, even after all the news and all the business impact. Just recently, I saw some DMZ servers that hadn't been patched in 3 years. I'm not sure how that happened, and I'm not sure how they had only been rooted for Bitcoin, which I was like, honestly, that's like the least bad thing that could have happened out of all the possible outcomes. How detectable this is, not terribly hard to detect. There's a lot of automated security testing tools and manual security testing tools that will, like, if they see a SQL server, they'll start hammering it with usernames and passwords, just attempting to see if they can get access to it, right? Or they'll try to log onto servers, see if root is unprotected, that type of stuff. So what the impact is moderate, right? This can happen at any time in the application, or this can any part of the stack. So it could be anywhere from your app server to your SQL database to your Kubernetes cluster to your Windows server to wherever. Once a user is able to break that, they're able to exploit whatever is stored in those systems. So let's take a look at what this looks like. The one I've seen is most common for us, for application programmers, is where people are leaking stack traces. Now this might seem like a kind of weird one, but you got to remember anything you let leak out to user or to the, come on, there it goes. Anything you let leak out, people can use to exploit your system, right? So if we take a look at our startup, pretty common. The problem here is that when somebody set this sucker up, they set to use the developer exception page. Now the problem with developer exception page is that leaks out the full stack trace of whatever caused the issue. And attackers will often try to see that. It's like, cool, let's hit a stack trace. I don't know you guys, but if I see a stack trace, it's usually really obvious to me a couple things. For one, like what programming language you're using, right? If I see com.sun.java, I know it's Java. If I see, system.something, I know it's .NET, et cetera, et cetera. Where this gets more problematic for you, for security misconfiguration for your app, is I've seen this before in the wild too, where maybe somebody tries to figure out how to get a database connection erroring out, like to hammer the server 1,000,000 times. Wait for the databases to start timing out and stack traces to pop out. Well, this one particular client, they had done that, and some developer must have been having issues because they helpfully logged out the error message that I can't connect to the database. Here's the username and password I was using to attempt to connect to the database, right? Issues. So the easiest way to, again, prevent this type of stuff in your app is, don't leak stack traces. But let me show you some other more, other tools that'll help you out a lot better than that. Let me see, current slide. Okay, first, again, patch your systems. Second thing is in the room right after me, James is doing a pretty awesome talk on managing infrastructure in TypeScript. This comes out here, you use this. So you want to manage your infrastructure as its code, and you want to use what's called desired state. You want to set up your servers with a known good security patch level, security configuration, and roll that out to all your servers automatically. If you're interested in that type of stuff, again, come, I think it's, it's in the same room. Come right after my session. Follow guidelines on configuration management, right? Go ahead and Microsoft publishes these, all the major things. Go through the security hierarchy guidelines for all your servers and apps. Separate out application roles. This is less of a problem now, thanks to microservices and containers. We don't, 10 years ago, we used to put everything on some poor overloaded iron box in a rack. Had the database, IIS, everything was running on that thing, which means if one of those things had a vulnerability, they had access to the entire stack. Nowadays, that is less common. Again, reduce attack surface, right? Remove features you aren't using, and by default, remove accounts and passwords, or get rid of defaults. Cross-site scripting. So usually have more import to the JavaScript folks in the audience and TypeScript folks, but so here's the threat vector. This is actually pretty easy to determine. There's a ton of tools out there that'll scan your site and look for XSS vulnerabilities, or ways to exploit your site using XSS. So what an XSS attack is it's a way for a lot of user actions are really actually pretty easy to mimic, right? Like if I click on something in a link, maybe that post data to an endpoint. What an XSS endpoint, XSS allows you to do is arbitrarily execute a single action as a user running the website. So a lot of times this is sent as like crafted social media links that a user clicks on, and then executes arbitrary JavaScript running on that page as that user. This is why it's up here pretty high. It's the second most prevalent one. It's seen all the time, but it depends on what they're able to do and what JavaScript they're able to inject in the page is how big of a problem this is, right? Especially in this case, it's moderate for reflected. We'll get into reflected versus stored here in 1 second. And it's pretty severe for stored XSS. So reflected versus stored. Okay. So reflected is, again, like a social media attack. You're sending an email link that somebody clicks, executes some JavaScript. Stored is different. What stored is, and the most famous example is actually the MySpace days. I'm sorry, I'm going way back in time. Way back in time, somebody discovered on MySpace that they was vulnerable to XSS vulnerabilities. So what they did is they, on their page, when a user loaded it, it would run XSS as that user, friend that guy, and post a comment, a post saying, hey, look at this awesome thing. Not terrible, right? Creates a post, adds the original user as a friend, that's it. Within about 3 hours, the guy had more friends than the founder of MySpace. I can't remember, it was like 10 million, and had basically shut the entire system down. To their credit, MySpace fixed it really fast, but that's called stored XSS. The reason is the vulnerability that he was able to store it inside of like a SQL database, so what MySpace used back in the day. So anytime a user loaded that page up, boom, they're running that JavaScript, which friended him, immediately. Out of all the things that could happen in MySpace, it's probably the least bad outcome. All right, let's take a look at what this looks like in code itself. Let's put back over to our, so we're going to go to our views for this one. And oftentimes this doesn't look, as a developer, it might not look terrible, and it's only once you realize once you get some bit of understanding what's going on behind the scenes that it's problematic. All right, so I have some inline JavaScript, right? I'm going to grab location off the window, split by equals, and grab the name, right? Because I want to say, welcome to the blog, Bill. So I'm going to go, cool, I'm going to grab that. If it's not equal to undefined, I'm going to get an element by ID. I'm just going to set the .innerHTML to welcome space Bill Dinger. First glance, this looks pretty innocuous. The problem is inner HTML, without escaping the name, the browser is going to execute whatever it reads here as native code, as JavaScript. So what an attacker can do is send me a specially crafted link, myblog.com/something/name or !name equals JavaScript. If I click on that link, everything that's in that script tag, if that equals, is going to be executed right here. Again, maybe that's nothing terrible, but it's able to execute with the same permissions as the user is on the web page, just like the user is. The easiest way to fix this in this particular instance, I said that before, so inner HTML is the DOM processes that and it executes it. Anything inside there just flat out executes it. There are a handful of these that'll do that, but recently, well not recently, about a decade by now, there's a couple of DOM nodes like text content, where even if you put script tags in there, whatever else, the browser's going to ignore it and won't ever execute it. There are quite a few techniques, though, for fixing this. We'll go over them real fast. Oh, jeez. Come on, laptop, don't blue screen. Yes. All right. Protections. So escape untrusted data. Again, there's the OWASP protection cheat sheet we'll go over. There's a super sweet thing called CSP, Content Security Policy, that actually says on this particular web page, only run these exact scripts, JPEGs, whatever, that completely prohibits this. Never insert untrusted data into JavaScript APIs like inner HTML. How many people use HTML raw on a regular basis inside their MVC views? Good, not many hands, nobody hands. No hands. This is actually the first time I've ever given this talk where nobody admitted to that. That one bypasses. By default, MVC escapes out all that for you, unless you use HTML raw, in which case it just will arbitrarily spit that out. And again, use frameworks that support automatically escaping XSS by design. The good news is, React, Angular, all the modern frameworks take care of this. All right, insecure deserialization. It's another brand new one that just came out with the 2017 version. So what insecure deserialization is it's app specific, and off the shelf, it can't usually be done. There's no like script kiddie version of insecure deserialization. Okay? What it actually is customizing a specific payload, like a JSON payload, that's exploiting how a browser hydrates objects and to execute arbitrary code on your server. I'm going to show you what this looks like. This got included, by the way, on the OWASP, not by OWASP themselves, but like people thinking that this will become a bigger problem in the future, and I'll show you why they think that. Let me show you what this looks like in code. This is one of the newer ones. It's one of the harder ones to kind of get your hands around. But you consider how many times inside of our code we go through, we pull up data, we hydrate it, we serialize it. All right. Here we go. Oops. There we are. Okay. All this looks pretty normal, right? I'm expecting a JSON object coming in. It's as a feed object. I'm going to go ahead and deserialize it and create a, go ahead and serialize it. Deserialize it back into an object, create an object, add to my database. The problem is this, type name handling auto. If somebody crafts a very specific JSON payload, and it looks like system.object.namespace or .file, when the .NET hydrates and creates that object, it'll also create that system.io.whatever. Maybe it's IO file system. And the user is able to arbitrarily create objects on the inside your program that you didn't realize could be created. There is a good white paper at the very end of this I'll link to, and I'll show you guys what this looks like with great examples. The key thing here is, for the most part, the newest versions of .NET automatically disable all this, so you're protected against it. But if you're using older versions, and that link has with older versions, you are vulnerable to this. Or if you set this type name handling to auto. Okay? If you do that type of stuff, people can, with very specific JSON payloads, create arbitrary object classes and execute as your IAS server, or whatever it is you're running. So there's a couple ways of taking care of this. The easiest way, again, is to use stick to a well-known framework like JSON.NET. Implement integrity checks that so people don't modify your payload. And if you must, use a strict whitelist. A9, using components and known vulnerabilities. So this one was ranked, luckily, pretty low recently. There's a lot of NPM packages. There's a lot of .NET. You migrate through NuGet packages that have vulnerabilities in them. And people rarely update their packages, right? It's pretty rare for me to see people like, I'm going to go into NuGet, I'm going to update my packages all the time. Like, people don't want to touch that stuff. They get afraid, right? The problem is if you don't do that, maybe some attacker is able to see, well, this version of whatever of JSON.NET has this JSON vulnerability. So the impact is whatever. That's why the impact is listed as severe, because usually these lead to remote code execution attacks. Okay, it's just like having an unpatched file, server. If you're usually able to determine you're using an unpatched library. Again, just like we saw in the keynote, right, with the struts vulnerability, you get the exact same problem. The good news is there's a couple easy ways to protect yourself. Again, you can just keep your package up to date. There's also something sweet. OWASP puts out what's called an OWASP dependency checker. You can actually add it to your .NET builds. It'll scan your listed NuGet references. If it finds vulnerabilities, it'll fail your build. It's pretty awesome. And it's free, just built in the framework. If you're using something like NPM, nowadays, newer versions of NPM use NPM audit, which will actually scan NPM itself, look for vulnerabilities, and again, fail your NPM builds if they detect vulnerabilities by default nowadays. So this is, again, starting to become great. Last one we're talking about real quick is insufficient logging and monitoring. So what this means is not exactly a vulnerability in and of itself. Like, if I don't have logs, it doesn't necessarily mean, it's not like I'm getting hacked, right? What it means is that if an attacker starts attacking me, I have no way of knowing. Okay? Almost all of these attacks start with somebody hitting your server in weird ways, doing stuff that a regular user wouldn't do. Hitting every API endpoint you have, scanning all of them for random IDs and that type of stuff. So the reason they include this, another good example, this is also the Snowden rule, right? Like, what Snowden did by scraping every single database in the NSA system wasn't normal user behavior, right? That's how this rule is targeted towards. You should have decent logging and monitoring to detect certain patterns that are typically you wouldn't see in a user behavior. Okay? Without this protection, the impact is moderate, right? Almost every successful attack starts with vulnerability probing. Almost every one. So a couple different ways to fix this. Again, use a well-known auditing and logging framework. In this solution here, we're using audit.net. It's a great one. Make sure the logs are pretty easy. Use a log aggregator, right? Ensure your high-value actions are stored in an audit log that's like a read-only append mode, so you can go back and look, like is somebody hitting this API 5 million times? And set up monitoring and alerting for suspicious activities. So some resources for you here before we go. Again, I'll post the slides at the very end. .NET Security Cheat Sheet, the Top 10 Project, the series, security. Troy Hunt's got a pretty good OWASP Top 10 series on the previous version, the 2013 version. But if you happen to still be a web forms developer, I salute you because whew, somebody's got to. If you happen to still be a web forms developer, that's not a bad one too. It's got a lot of web form specific stuff. And again, I alluded this to at the A7, the JSON vulnerabilities. Blackhot.com, that paper right there, will show you exactly what a payload looks like that you can use to craft those JSON objects and execute arbitrarily code. I think I am exactly at time. If you have any questions, you can find me afterwards, or I'll be right up here for a few minutes, or I'll be right outside. Thanks, everybody.